In the real world, you definitely do not use a heavy industrial press to crack a single walnut. Solving a quadratic equation presents 5 different tools: graphing, factoring, completing the square, taking the square root, and the quadratic formula. Most exams simply tell you to solve for x. Deploying a heavy-duty formula on a simple equation burns through your limited test time, while trying to use a quick shortcut on a complex equation leads to a dead end. This guide provides a strategic diagnostic decision tree. We are identifying exactly when to deploy each specific tool. True mathematical mastery involves precise diagnostic recognition. Identifying structural patterns allows you to spend your mental energy on the calculation itself, rather than the search for a strategy. Every path begins with standard form. Moving all terms to one side allows the equation to equal 0, arranged as ax squared plus bx plus c equals 0.
Depending on your teacher, you may hear the terms roots, zeros, solutions, or x-intercepts. These are different words for the exact same numerical result. Graphically, a quadratic forms a parabola. The roots are the specific points where that curve intersects the horizontal x-axis. The purpose of every solving method is to find the exact numerical coordinates of those two intersection points. Analyzing the equation's anatomical structure determines which tool will find those roots most efficiently. When the structural conditions are right, you can bypass the heavy lifting and accelerate immediately to a final solution. First diagnostic check. If b equals 0, use the square root method. It's fast, but forgetting the plus or minus symbol costs half your answers. Second check. If a equals 1 and factors are obvious, deploy the zero product rule. You are searching for two numbers multiplying to your constant and adding to your middle term. Beware of analysis paralysis. Time to factor an equation with irrational decimal roots wastes precious minutes without producing a result. Square roots and factoring are precision tools that work perfectly as long as the equation's structure is perfectly aligned. The third diagnostic check looks for a leading coefficient of 1 and an even middle value. This combination makes completing the square a viable path. This method is a physical geometric transformation. Look at the blue x squared and green x rectangles. Together, they form an incomplete shape. Taking half the middle term and squaring it calculates the exact area of the yellow piece needed to physically close the square. Manufacturing this perfect square allows you to find the graph's vertex with almost no extra work. However, if the middle term is an odd number, this method introduces nested fractions. Forcing it onto odd numbers creates a minefield for arithmetic errors. Completing the square is a structural hack for even numbers, but it becomes a liability when decimals are involved. When factors are hidden and the numbers are messy, you drop down to the final failsafe, the quadratic formula. Once the equation is set to 0, you extract your a, b, and c coefficients and plug them into the formula. This tool is universally reliable. It will solve any quadratic in existence, providing exact values for irrational and imaginary roots. That reliability demands a high cognitive load. Handling the discriminant, the part under the square root, is often where arithmetic mistakes with negative signs happen. Graphing is another universal option, but without a calculator, it's too inexact for complex decimal roots. Use it mainly to visually verify your algebraic work. The quadratic formula serves as the ultimate safety net, but relying on it for every single problem is an unnecessary drain on your mental bandwidth. Mapping these tools to your specific testing situation creates a clear comparison between reliability and efficiency. For a student cramming for a test tomorrow morning, ignore completing the square. Focus your mastery on factoring and the quadratic formula to survive. Spend exactly 30 seconds attempting to factor. If the numbers don't reveal themselves immediately, bail out and deploy the formula. If your goal is to maximize speed on the SAT or ACT, you need to memorize every method and deploy them based strictly on the equation structure. Use the square root method the second a middle term is missing, and complete the square whenever the question asks for a parabola's turning point. Mathematical fluency improves as you begin matching your effort to the specific demands of the problem. There is one universal safety protocol that applies to every student and every method. Nearly every algebraic disaster stems from forgetting to set the equation equal to 0 before you begin your work. Screenshot this completed decision tree. Use it as a master reference map to diagnose your equations before you pick up a pencil. By letting the structure of the equation dictate your strategy, you evolve into a strategic problem solver.